to the channel. Today's lecture will be focusing on another of the Earth processes, this time the rock cycle, the formation of soil, and then the different soil types. Let's begin. So we're going to dive into the rock cycle. Now the name, the rock cycle, gives you an indication of what is going on in this process. The very term cycle means that this is something that is repeated. And in the case of the rock cycle, any rock can become any rock, depending upon the forces that are applied upon it. So the three major types of rocks are sedimentary, those formed strictly from grains and pressure; igneous, material that is formed directly from heat; then metamorphic, a mix of the two, heat and pressure. Now we're going to take a look at a couple of graphics that show these processes, and you'll see that any material, as I said, any material that you start with can end up becoming any other type of rock. So as we look at this graphic, you can see all three major types of rocks are represented here. The igneous rocks, both intrusive, meaning they never reach the surface; extrusive, meaning these are erupted; your metamorphic rocks; and your sedimentary rocks. Now let's just follow one path. Let's take that magma coming up, going through that crystallization, coming up to the surface, being erupted as lava from a volcano. That magma would then crystallize on the surface, it would harden, but then it would be exposed to the environments: rain, wind, weather, temperature shifts, and so that would start to break down. It would have a weathering effect. It would be broken into smaller and smaller pieces. Those would then be transported. They would be deposited either by wind or by water movement, and then over periods of time that would sediment and become rock. Now here's another version of that rock cycle. You can see again the same processes. Heat and pressure from the sedimentary rocks will form metamorphic rocks. The same thing will happen to an igneous rock if it is exposed to heat and pressure. Whereas both of these types of rocks, both metamorphic and igneous, both will go through weathering and will eventually become sedimentary rocks. As I said before, depending on the exposure to the forces, whether it be heat, pressure, weathering, a combination of those two, will depend on what type of rock is formed, and this cycle will then repeat over and over and over again. So as we look at this graphic here, you can see it's broken down into the three main rock types: the sedimentary, the igneous, and the metamorphic. Again, sedimentary formed from particles. So your classic example would be the clastic, the conglomerates, the sandstone, the shale. You also have your chemical sedimentary rocks, limestone, salt. You also then have the biologicals, which the best example would be coal. Then your igneous rocks, again, those formed from heat, crystallized magma or lava erupted. The intrusives, that would be your granites. Remember, intrusives stay underground. Then your extrusives, those would be the erupted material, your basalts, your andesites. Then we move to metamorphics. You again have two classifications there: the foliated, which actually have stripes, and the non-foliated. Examples of foliated would be your slates. Non-foliated would be marble. So now let's take a closer look at each of these rock types. Igneous rocks, again, form from solidification, the crystallization of melted rock, magma. Magma either cools underground, forms granite, something like that. Magma is then erupted as lava. It then is exposed to the atmosphere. It cools, and you have different kinds of igneous rock that are formed. Some of them have very large crystals. Those would be the magma that would cool underground, your granites. Above ground, those crystals are very, very small, very difficult to see. And then one of the most famous of the extrusive igneous rocks would be your obsidian, your Apache tears, the glass looking smoke rock. Clear, almost clear, very sharp, can be used for as a cutting tool. So if we're looking at granite, again, that's very commonly seen as countertops now. We also have buildings that are made out of granite. And if you shine a light on granite, you will see the sparkles. That's the mica and the quartz and the feldspar. We use granite because it is very, very hard. So if you're thinking of one of the hardest rocks, the hardest mineral of all would be a diamond. But then closely following that is granite. Some of the hardest granite in the world is found right here in Yosemite, and that was formed because of the way it cools. Now, contrasting with granite would be the basalts. Basalt is erupted material. This is the most common of the igneous rocks found all over the planet. And it's very difficult to see any crystals in this because it would have cooled very quickly. Again, this is from erupted material, formed where lava is thrown out of the volcano and then is exposed to the environment. It cools very quickly and forms your basalts. Here is an example of what I was speaking about earlier, the obsidian natural volcanic glass. Again, volcanic material, lava that is erupted to the surface, and then it cools very quickly. And again, this only forms from certain types of lava. Lava that is very runny, flows like water, similar to what you would find in the Hawaiian Islands. Again, when you fracture this, when you chip it, it actually creates a sharp edge, a conchoidal surface, almost curved, looks like a crescent. And so this can be used again as a spear tip, as a knife blade, as an arrowhead, and it was used quite frequently. Another common igneous rock would be pumice, probably a very famous igneous rock, as this is what buried the cities of Herculaneum and Pompeii, um, covered with the ash and pumice from the erupting Mount Vesuvius. Another igneous rock, again, similar materials as granite, that would be rhyolite. It would be very difficult to see the crystals unless you are using magnifying glass, but again, this is an intrusive rock as opposed to pumice, which is extrusive. Pumice, incredibly, can float on water because of all of the air spaces caused from the exploding gas and that material cooling as it's flying through the air in an explosive eruption. Now, moving forward to the sedimentary rocks, again, these are formed in layers, usually from the deposit of sediments. And then those sediments, the size of those particles, oftentimes will determine the type of sedimentary rock that you're looking at. So, if we're looking at sediment sizes, the actual classification of those sediments, from biggest to smallest, we go from the boulders, and again, that's not what you would typically think of as a boulder, but about 256 millimeters would be maximum size, or that would be the minimum size of a boulder in a stream bed. Then you have cobble, then pebbles, granules, sand, then silt, and then finally clay. And again, these materials then affect permeability of that rock as well. The larger the particle, the more permeability, the more spaces, the more gaps for those materials to flow through. So again, clastic rocks are made from cemented sediments. They are classified by their grain size. So if we're talking about a conglomerate, well, that is a collection of stones, basically pebble size. Then we go to your sandstone. Well, guess what? It's made out of sand particles. Shales are made out of a silt, even smaller, and then your clays would be the smallest particles of all. The second classification of the sedimentary rocks are your non-clastics, your evaporites, or your chemical sedimentary rocks. Again, these are precipitates that settle out from a solution. So an evaporate would be a salt. Salt is a sedimentary rock. Salt in its rock form. Another evaporate would be limestone. Limestone is made from calcite. Calcite is from the deposits of seashells. The last classification of the sedimentary rocks would be your biologics. And again, the most famous example of a biologic is coal. We know all about coal. It is the remains of ancient swamps created about 225 million years ago, and then we use that as an energy source now. Anthracite is the very best coal, the highest energy for volume. There are other classifications of coal. You would have the second grade, which would be bitmous, and then the third grade, the worst, is lignite. Petrified wood would be another example of a biologic sedimentary rock, again made from organic material. So now the third main type of rock, the metamorphic, are made from the combination of heat and pressure. Remember, igneous is all about heat, sedimentary is all about pressure, metamorphic is the combination of the two. And just like the name implies, it is a chemical and physical change to existing rock based on the forces that are applied. So you have regional metamorphic rocks, those are affecting a large area caused by plate tectonics, the motion of the earth itself. Can you imagine the heat and the pressure that would be occurring from the grinding of continents against each other? Second type would be your contact metamorphism, and that's going to be contact next to a magma chamber, erupting lava. The heat then bakes the rock with the pressure and changes its chemical and physical nature. So let's take a look at some different types of metamorphic rock. The first types are your foliated. They almost look like they have bands in them. They have lots of mica, they're very sparkly, but those are not crystals. They are not crystals, they are particles, and they've actually been changed. The layers can look like a sedimentary rock, but if you look at the layer closely, you can see that it's not a layer at all. It's actually chemical bonding that is going on inside of that rock, formed from the pressure and heat and the chemical reactions that happen inside. Second type of metamorphic rock, the non-foliated. Those do not have any banding in them or anything like that. Again, famous metamorphic rock would be marble. Marble actually comes from limestone. Limestone was then exposed to that intense heat and pressure, changes its chemical composition and physical structure, and forms into marble. Again, marble, no banding, no layering looking things along this rock. We use that for monuments, we use it for building materials, we use it for countertops. Hard rock, but again formed from limestone, a fairly soft sedimentary rock. So in this geologic map of California, you're actually able to see the primary material in each of the different regions of California and take a close look at the Central Valley extending all the way from Northern California down to the lower part of Southern California. Look at the common material that is there, all that clay. That's all the clay that we have from the deposits from the Sierra Nevadas and from the San Gabriels surrounding us on both sides to the east and the west. So now that we've taken a look at the rock cycle and the formation of these different types of materials, the igneous rocks, the sedimentary rocks, the metamorphic rocks, and how those processes affect the actual formation of these materials, now we can start to think about how does this break down? How do we get the different types of soil? Where does soil actually come from? Well, we do know it's made from rock. And so if we're thinking about how does the soil go from being these stones to something I can grow vegetables in, it goes through a process. So let's go and start looking at the actual formation of soil. So if we're considering how soils form, I want you to think about holding some dirt in your hand and looking at what it actually is made of. Again, the components of that soil really can tell you how it was made. It all starts with physical weathering. Those rocks break down, exposed to the wind, exposed to rain, exposed to temperature changes. And those small particles are then transported. They begin to accumulate on the surface. Over time, they start to form layers. Chemical weathering then starts to dissolve and change the actual minerals that are in those small particles. They continue to have the physical weathering breaking down. Again, layer is laid down upon layer over time. Pressures are starting to be involved. Then you have all the decomposing organic material from plants and animals that again mixes with those accumulated soil materials. And again, this is all happening over hundreds and thousands of years. And in those materials, you have different size spaces, voids that are filled with air, filled with water, filled with nutrients. Those are then exploited by plant roots that then cause even more channels. And those continued physical and chemical changes, hundreds, thousands of years, produce the actual soil that we have and the soil horizons. So, if we're looking at that process of how soils form, and we can start to see that there is layering that is starting to happen through the accumulation of particles, through the chemical breakdown of the materials, through the deposit of organic materials on the top. And so you start to see what are called horizon layers. The O horizon, that top organic layer, the A horizon, that's where you have the accumulated materials. Then you have the B horizon, the C horizon, and then down to the very bottom, the E horizon, the bedrock. And so now by looking at those horizon layers, we can determine a lot of information about the nutrient quality, the formation of that soil type, and where it is. Surprisingly, climate plays a huge role in the soil type you would find in that location. Let's take a closer look at that. So these different soil types forming in different climates, we're really going to be looking at the horizon layer, again, that top layer. The A and the B layers are also important, but in this case, the horizon layer is really going to tell us what's going on. So in prairie soils, we have that really nice dark surface horizon layer, rich in minerals, full of decomposing materials, and that's why it forms in grassland areas, widespread across the mid continents. The forest soils have a light gray upper horizon, rich in aluminum and or iron. If we're thinking about the Sierra Nevadas, that's rich in iron, and they form in warm to cool humid regions, coniferous forests. Think of pine trees. Your tropical soils are reddish, and so that horizon layer is iron oxide rich. The reason it's red is because it's rusting. It is depleted in nutrients and it will form in those humid and tropical environments. Your organic soils, dark colored, rich in decomposed organic matter, and they form in those swamps. And if you think about forming a rock from that, that's why you would get coal. The desert soils are rich in calcium carbonate, so you're looking at lots of limestone, lots of calciums, lots of halites, and very arid, very small particle size, very nutrient poor. Your tundra soils are interestingly rich in organic material in the upper layer. However, right below that, you have a mineral rich layer, and below that, you have frozen ground, and so impenetrable. Remember, in that Arctic tundra soil, you have a very short growing period, and so you have very little time in order to establish that organic rich upper layer. So now we've looked at the entire process, the rock cycle, the formation of those raw building materials, the igneous rocks form from heat, the sedimentary rocks form from particles and deposits and evaporation, The metamorphic rocks formed from heat and pressure, and that cycle of how that material is reused and repurposed over and over again. Then, through weathering, both physical and chemical, you have the accumulation of these particles breaking down, forming layers, and over time, forming soil. And then finally, by looking at those soil layers, those horizon layers, we can determine the soil type and the climate that that soil can be found, including the richness, the fertility of that soil. So, hopefully, this mini lecture on these earth processes can clear up some confusion or open a few windows on how this process actually occurs and why you find the kind of dirt you find where you live. As always, if you have any questions, don't hesitate to put them in the comment section and stay safe, stay home, and wash your hands.